Today's lesson is on perfect competition. So we're going to be discussing firms that exist in this industry and their behavior in decision making. So let's go ahead and get started. Okay, guys, so welcome back to another fun-filled episode of Quintino Teaches Microeconomics. I'm super excited that you're joining me on this lovely evening. And yes, those are my children fighting in the background, but we got to roll with it and figure out whatever we got to do. So let's just get to it. So in this case, I'm going to be talking about perfect competition in the short run. And there's always going to be an industry graph and a firm graph side by side. So this is going to be the market for apples, let's just say. And this is going to be Aaron's apple farm. Okay, a firm in this market. So we already know price and quantity are our axis labels. We know we have a demand curve, we have a supply curve, and we have an equilibrium in the market. I'm going to put 1,000 pounds and I'm going to of apples, and I'm going to put it at $4 a pound. Now, a perfectly competitive industry is always going to be a price taker, and what that means is that we as consumers set the price. Our demand for these is equal to the price. So if we go to Stop and Shop, Food Town, if we go to ShopRite, we're going to see that the price of apples are pretty much identical. There's zero incentive for anyone to charge more or less, and mainly because of the fact that, again, it's apples. We don't go around like we do jeans and what kind of brand and how they look and how they fit. We pretty much just look at an apple and decide whether or not we want it, and we eat it. Most of us don't go around saying, is that apple from Aaron's farm? Is that apple from someplace in California or in Georgia or in Florida? No, we don't talk like that. That's ridiculous. So most people, they buy what they want when it comes to perfectly competitive products. So in this case, $4 is what the price is, but it's also our demand. So the firm's demand curve is perfectly elastic. Okay, so for this, the demand curve and the price are equal. And I'm just going to write this here and I'll explain it first in a second. Mr. DARP. Okay. Mr. DARP stands for marginal revenue, demand, average revenue, and price. And in a perfectly competitive firm, they're all equal. So I'm just going to put some numbers down here, right? If we buy 1 pound of apples, we're going to spend $4. If we buy 2 pounds, we're going to spend $8. A change in 4. If we buy 3, we're going to spend 12. Another change in 4. So marginal revenue, the change in total revenue is always 4. The demand is perfectly elastic. It's set at 4. That's also our demand curve. It's also our price. Okay, it's also average revenue, because then, again, when you divide these things by the quantity, you're going to always get 4. Okay, so this is how a single firm in a perfectly competitive industry, this is right now how their demand curve looks, and this is the industry graph itself. So now, moving on. Another reason why we study these is to kind of go over firm behavior. So for example, should a firm produce? Should this firm stay in business? Should this firm or is this firm making a profit? And if so, how much? Is this firm incurring a loss? So these are the things now where we're going to visually see represented once we add in our cost curve. So should Aaron produce? We can't tell right now. The only thing we can tell is that he sells every single pound of apples for $4. That's the only thing we can actually tell right now. So you recall we have 3. I'm going to color code them so they look a little bit different. We have marginal cost, which is the fish hook, which is the difference in total cost, or the change in total cost over the change in quantity. It immediately lowers when specialization kicks in, but because of the law of diminishing marginal returns, it starts to increase yet again. So I call it the fish hook because that's what it looks like. Marginal cost curve. Okay. Now, with this, can we see if the firm should produce and how many units should be produced? We can answer this question because of the good old profit max rule. MR equals MC. This was in the notes and the video, at the end of the video that I did last and at the end of the note packet that I gave you guys last on cost curves. This is our rule, our profit maximization rule, or loss minimization rule. This is what's going to carry you for the rest of this course. It's how we're going to make decisions. It's how firms make decisions. It's super, super important. But we can see where MR and MC meet. So the marginal cost curve and Mr. DARP intersect here. And I hope I got it like to look kind of 5. We're going to call this 5 units. Okay. So how many units should be produced? 5. Now we have something else called the average total cost curve, or ATC, right? Total cost is our fixed and our variable costs, and the average of that is just per unit based. So I'm going to go in and I'm going to draw the average total cost curve. It's just a U-shaped. It could look a little bit different depending on the type of firm, but it's always going to be in a U shape. The lowest point of the average total cost is what intersects the marginal cost curve. So however you want to draw it, for me, I just kind of getting used to it now. I'm going to my lowest point, average total costs. Now I have one more left, and it is my average variable cost. These are super, super important, the 3 of them together. And remember, the average variable cost will approach average total cost, but they will never, never intersect because the distance between them at any given quantity is equal to the average fixed cost. Okay, so these are the 3 most important curves, and these are going to help us answer the rest of the questions on this page. So question of, should the firm produce? Right now I'm saying yes, and I'll explain why it has to do with these guys as well. What is the profit or minimum loss here? I can tell you that Aaron is making a profit in this business. And the reason being is the location of the curves in regards to a quantity of 5. Shutdown rule. Definitely Aaron should not shut down. He should not close up shop. He is actually doing pretty well for himself. So that's what we're going to kind of look at now moving forward. I know it's kind of hard to see, but you always kind of want to like pinpoint the points at this quantity where it intersects all the curves. So it intersects average total cost here, average variable cost here. They all play a role in calculations. They all play a role in how much profit is Aaron's going to get or how much loss he's incurring. He's also going to show us how much Aaron spends, or what his costs are, what his total revenue is. So it's really important to kind of, map this whole thing out. Okay, so I just kind of redrew it because there was a lot going on. So like I said, in this case, this is Aaron. Sorry about that. Apples. And this is the market for apples. Aaron is profitable. And I know this because of the location of the average total cost and the average variable cost. So first we find MR and MC. So we know the quantity is 5. Okay. And that is what's going to lead us to figure out this. So if the average total cost curve is below marginal revenue at this point. So again, we go to the quantity of 5 and then we go up and look at the intersections. At 5 units, the average total cost curve is below. It's right here. It's below. The average variable cost curve is also below. They're both below. That's meaning that is going to represent that this company is going to be profitable. And by how much? I'm just going to kind of put 3 here. You go across from the ATC intersection at that quantity, and you go across to the y-axis. This shaded region, a lot of shading, a lot of coloring, like I said, is your profit. So in this case, Aaron's profit. Okay. So now this is a great example. Also, I can kind of help you with the math because they will ask you, and I have a very strong belief now that while you aren't going to have to submit these graphs on the AP exam, you're going to have to draw all this to conclude all of this, and they're going to ask you something along the lines of total revenue, profit, or a loss amount. They're going to ask you total cost or variable cost. They're going to ask you whatever they want to ask you, and you're going to have to make sure that one, you've got this whole graph drawn correctly. You follow these rules over here on the side to make sure that you're stating that it is a profitable company, and then you're going to have to actually provide them with your reasoning, provide them with how you came up with, provide them with all these rules on the side as part of your explanation, and then they're going to ask you for calculations. So total revenue, if you recall, that's an R, is price times quantity, which is nice and easy. We already know the quantity is 5. We know that it's 4, so it's really 4 times 5, which is 20. Awesome. We know costs in this case now. I'm going to highlight the cost in yellow. Our average total cost curve at 5 units intersects here at 3. Okay. So that 5 times 3. Okay. Or 15 in this case. We can see that the profitability, you could either subtract the 2 and get 5, or you can go up here and find the area of that rectangle, which is 1 times 5, however you want to slice it, 5. So 5, let me erase this because it's crazy. So it's not a loss, it's a profit. It's $5. Total revenue is 20. Total cost is 15. And if you wanted, and if they were asking you, I could also say that, your average variable costs, and you can figure out that they were 10. So this is just an example of a short run perfect competition a firm in that particular industry that is profitable in the short run. This is what it looks like in perfect competition in the short run when there's a firm loss. So again, if this was the Apple firm versus Apple market. All right. So with this, we're still going to start MRMC. So I'm going to look where my MC and MR meet. In this case, it's so in between, but let's just pretend like it's 5, okay, guys? Let's just pretend. I know it's a stretch. It looks like a little bit more like 4 3/4, but for this exercise, for my sanity and your sanity, we're going to pretend like it's 5. So we're still producing at 5. And remember, I told you to go up to, at that quantity, all curves at that particular quantity and make a designation. So now this is our total cost situation. This is our profit and loss situation, and this is how much our variable costs represent. So now there's a problem. Now my average total cost is above. My average variable cost is still below at this particular quantity, which is good. That's what's showing right here. I'm still going to produce here. I'm still going to produce the 5. Now, however, let's just keep it very simple. Now I have a loss. So I'm going to shade in this whole area. This is now a loss for the firm. And that's how we are drawing it. Because the entire cost, I'm going to try to make this like as bold as I can. This is the total cost representation. So technically, this whole thing is costs, our costs, excuse me. But since this is our revenue line, okay, this is how much we're actually losing. We're actually making the rest of this. And you're not even seeing what I'm doing. I should probably shade it in. You're making this in your revenue. Unfortunately, there's this excess on top too. That is also part of the cost. So you are going to still produce. You're still going to produce. We're not going to shut down. But you are going to incur, or this business is going to have a loss. And we're still producing 5 units, but now we have a different representation. So I'm just going to write it here. Total revenue in this case is still 4 times 5 because we're charging $4. 5 is the quantity, excuse me. Total cost though, unfortunately, is 5 times 5. All right, variable costs are 3 times 5. So you can see that the firm is covering all its variable costs and some of its fixed costs. Unfortunately, as I have right down here, a good example of this in real life is what's really happening right now to the small independent firms that exist in Wayne and in many of the cities in the United States. They're not shut down yet. They're still operating. Hopefully, things will change. Hopefully, with this whole situation, things will change sooner than later, and hopefully they don't have to shut down. But it's a good possibility if things don't turn around that we are going to unfortunately see the dying of some of small businesses, which is actually really, really sad. Okay, if the average variable cost, okay, and I think I put this on the slideshow, is above the marginal revenue, we shut down. That's where a firm isn't covering anything. Okay, it's actually more costly to be open and operate than anything else. This would be a devastating situation, but unfortunately might be a hard truth in a month's time. So here are the questions. This is the situation. So I'm just going to kind of go through this. First things first. 1, you want to look for MR equals MC. Okay, 2, you want to look where the average total cost, average variable cost curves at that point of MR, MC quantity. All right. Then we decide if there's a profit or a loss. And then we can calculate. Okay. And we can see, is this business worth it? Is this particular firm making money? So 1, how much output should be produced? MRMC. So this guy and this guy, where they intersect, I'm going to see right here. I'm going to go down and it's going to be 9 units. Bam. Okay. Now, average total cost, average variable cost, average variable cost isn't even on the map, but it's probably like this somewhere. With this curve being below MR, it's irrelevant. When this curve is below MR, we're making a profit. Okay, so this company is profitable. ATC is below MR. Okay, so again, I'm going to go here at the quantity of output at 9. And now I'm going to go over to here. This is the struggle I have when I make these things and pop them into Google. Drives me nuts. Completely nuts. So many reasons why I love Microsoft Office products, and this would be one. All right, so this is a profit. Yay! Okay, so now they want us to calculate. So total revenue, total cost, profit, amount. Question mark, question mark, question mark. Okay, so cool. I already did the profit amount. I made it nice and pink. Profit is going to be 1 times 9, or in this case, 9. So now my total cost is going to be, what just happened there? Okay. Okay, so now my total cost is going to be 6 times 9. And my revenue is $7 a unit times 9 units. There we go. And there you have it. Hopefully this video helped you. Obviously, I'm going to go a little bit more in depth with some more examples. So hopefully you can make it to some of the Zooms. I would definitely suggest it because it's a lot easier to see me do it in real time and then ask me a question immediately than to kind of watch and rewatch these. But I'm very grateful for those of you that are watching these, and I hope you find them slightly enjoyable and hopefully definitely, content-wise helping you out. So reach out to me if you have any questions. I hope you guys are doing well. I miss you guys. Talk to you soon.